Hello everyone, I'm Abdul Sattar. I've been recording this video for Dr. Tayyib Shah's channel. In this video, we are exploring about how we can use the spatial statistical tool called as Angelin's Local Moran's I tool. In this video, I'll be explaining how we can use this tool, for geospatial analysis and other purposes. So before explaining this tool, let me explain you the datasets on which I have used this tool. So this is a Union Council map of Khyber Pakhtunkhwa province. So there are around 319 Union councils, and this thematic shade map is giving the 6 standard deviation classes on which presenting the percentage of suitable buildings for solar panel installation for each Union council. So if I just explain you one standard deviation class, let me take this one with the light green color. The standard deviation class have the interval of 1, and it means that there are around 40 to 50% of the total buildings in these union councils are most suitable for solar panel installation. So so in this map, there's a clear spatial pattern of the datasets that presenting us the values of buildings or suitable buildings in the union council. So these spatial patterns can be used for multiple purposes. Like if I just give you an example, like how we can use the spatial patterns to know for different purpose. If we just want to know why there are some areas, some regions where there's a clusters of the union councils which are more suitable, and why there are places of which there are clusters of union councils which are non suitable. So it could help us just to identify the reason behind their suitability, whether they are suitable or they are not suitable. So if we just take the union council inside the Tordar district and Swabi district, Til, Shangla, and some part of Bune. If we just look at this pattern, it's showing that these union councils are with the waterway, and the water body could be a reservoir there. A reservoir is there, and these union councils are sort of a valley where the mountains are covering these areas. So this is a reason why these union councils have less percentage of suitable buildings. So if we just have the clear patterns, if we just have a clear shades of clusters, then we could also just tell the government or policymakers, just you have to you can target these areas where most of the union councils are in clusters having more suitable percentage of buildings. So this tool can enables us just to find the auto correlation between the values. Autocorrelation means that it takes a one point of the data and checks its values for its neighbors as well. Like if I give you an example, like if something is happening at one place, something interesting is happening at one place, there could be a probability that the same thing could be happen on that on its neighboring place. So just to know that thing, what thing is happening on its neighbor, we are using this special statistical tool just to figure out those values. So in our case, we are using this tool just to identify the percentage of solar eligible buildings within a union council, and also the value with its neighboring union council. So for that reason, this tool is most important for analysis purpose, for geospatial analysis and purpose. If I just explain you how this tool works, it takes a one point of a location and just checks the values with its neighboring values. It checks the neighboring values as well. If I just have to explain briefly in a very simple way, just how the process of checking the value is. So it uses the spatial statistical formulas just to locate the values of a region of interest around the region of interest, like the values around the neighboring points. If the value is so there could be two values, a positive value or negative value. If the value is positive, it means that the correlation that the correlation is there, and and the reason, and for that correlation there is a cluster of polygons which have the same values. And if the value of that process is negative, it means that there is no correlation and there is no cluster. So first we have to input the feature class, which in our case, which I was just explaining you, was the dat union console map. We just have to input the union console map here, union console feature class here. Then for the second input, we have to just tell which field we are taking. Same in our scenario, we just have to take the field called uh, percentage of suitable buildings. So that field would gonna so the ancient local Moran's I tool would just gonna find the clusters on the basis of that field. Like if some point, if any unit console have any particular value, then it would just gonna check the neighboring values around it. So here there are just the weight methods that the tool use. There are so many, like inverse distance squared, k nearest neighbors. But for the polygon cases, when we have polygon, we have a data set having a polygon, we just have to consider each and every edge of the polygon. For that, like if a polygon, we just have to check the values outside each edge of the polygon, so that there's no so there are correct values with us, correct clusters with us, having each and every neighboring value has been checked. So for that purpose, we use this option where we just check the edges, the values, the neighboring values outside the edges. And the other are the default option. You just have to don't have to change these options, and then we just have to run the process. So I have run this tool for my for the map where that for the game console map where with the spatial patterns for percentage of suitable buildings were there. So for the clusters that I got was this map. So which the same thing which I was explaining you before, but now we have a comprehensive data explaining which areas are having the clusters of having the high values, of having high cluster values. So let me first explain you what these values means, like high clusters, high low high, and low cluster. So high cluster means that the high value of one value, like one union console having the high value is surrounded by the high values as well. Like means that its neighboring values also have the high percentage of solar eligible values. So just if I have to give you the example, like if someone is having the high monthly income salary, and he's also living in the area where most of the person around him having the same high income monthly pay. So for high low cluster, it means that high low outlier, it means that high values are surrounded by the low values. So if I just give you the example, like crime rates, if in any area, if there is there are increased crime rate, but the but the areas surrounded it having the low crime rate. So in this, or same in this study, the union council having the high value, but the surrounded union council having the low value. So in this map, we aren't seeing any outlier of this class, because in our study, the union council having most of the union councils are in a special pattern where the mountains are around them. So it wasn't even there's a rare case that sometimes happens that all the union councils are around the mountain. The union councils are in the middle of the mountain, but there's a union council that is outside the mountains. So we are not seeing any cluster in our study, but there are clusters in some other studies like urban planning and some more. This I explained you the crime rates one. So the low high outlier is similar, like low values are surrounded by the high values. Low value union councils are surrounded by the high value union councils, like the union council cluster in Swat, in Aptabad, and these these clusters are low high clusters. So the last is low cluster. It means that the low suitable building So low percentage of suitable buildings are of having of union councils having the neighboring union councils having also the low values, the low percentage value. So for example, the pollution rate, if in any area there is low pollution rate, it means that the surrounded area could also have a low pollution rate. So because that area isn't generating any pollution, so the surrounding could also have low pollution rate. So in this video we have explored how this Enslin local models statistical tool works, and also how it is useful for geospatial analysis, for just to get the informed decisions, like if you just tell any policy makers that these cluster of union council having the most suitable buildings, so you can just start the campaign, just motivate the people in these union councils having buildings, just to install the solar panels. So, because the government could also not want to work on only or to just utilize their own resources for just one area. They want the maximum benefits from their resources. So for that reason, if government uh, build their sort of a headquarter in the middle of the cluster where the high values are there, so they can just operate on all the area around it. So this type of information is very important for geospatial analysis. Thank you.